When it comes to wavelet phase investigations, there are various aspects to consider. But within all that, cross-correlation and response phase remain two particularly useful tools for examining wavelet phase differences. Say you are dealing with two datasets, a reference dataset and another dataset with some overlaps between the two. You can extract and examine a line labeled here as AA prime that is common to both datasets. On the upper left is that line from the reference dataset. On the upper right, we have the corresponding line from dataset 2. We can then simply cross-correlate windowed portions of the two lines on a trace-by-trace basis. If the datasets are in phase with each other, the cross-correlations of the windowed content will exhibit a nice, temporally symmetric amplitude distribution. In the case shown here, note the lack of symmetry in the cross-correlations. Now that you have the cross-correlations to work with, response phase provides an easy way to quantify the phase of the associated waveforms. In this case, the response phase values indicate that the waveforms are roughly 38 degrees away from zero phase. That means that to match the phase of the reference dataset, we have to phase rotate the other dataset by 38 degrees. When we apply the phase rotation, we do see a change visually. To quantify the effectiveness, we simply repeat the cross-correlation step. Note that after the phase rotation, the cross-correlations exhibit a nice symmetric amplitude distribution. Taking these new cross-correlations through response phase confirms that the waveforms now hover around the desired zero phase. This indicates that the two datasets are now roughly in phase with each other.